Well, 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 who do we have here? I am Robert Edwin House, President, CEO, and sole proprietor of Robco Industries and the New Vegas Strip. Over the next 2 weeks, we will attempt to restore me to operational status in the form of an interactive artificial intelligence. An ambitious experiment. Welcome to Doomsday Protocol.
With the recent conclusion of Fallout Season 2, my obsession with the franchise has been revitalized. At work, I set my second monitor to a giant image of Mr. House, just sitting there, silently watching and judging me through the day as I work. And as cool as it looks, I want it to be more than just a background. I want to talk to him. Not through scripted dialogue trees, but like a real conversation. And with how far large language models have come in the past couple years, this idea finally feels possible. What if I could build a system that could hear me, think like Mr. House, and then answer back in his actual voice? A living, interactive version of Mr. House, right here in the real world.
This meeting has been a long time coming, hasn't it?
Yeah, you know what? Let's put 2 weeks on the clock. Let's talk constraints. First things first, I don't want this system listening all the time. Constantly open microphones are messy from both a technical and privacy standpoint. So instead, I want to make interaction intentional. I'll press a physical button to activate listening, speak my line, and release when I'm done. In the Fallout series, there's a moment where the ghoul activates Mr. House with a big red button. By pure coincidence, I happen to have that exact style of button lying around, so naturally, that's becoming the push-to-talk switch for this project. Some of the core experience constraints are that this must feel conversational. The response time needs to be fast enough to avoid awkward silence, and the interaction should feel natural, not like typing to a bot. This will drive latency decisions. Thematic and user experience constraints. The interaction must match the Fallout-style dialogue. The push-to-talk system isn't really part of that, but the dialogue box appearing with your input texts being there is definitely part of the game, and Mr. House responding in character. I really want to keep it from being a generic AI demo. I think there's enough of that stuff floating around out there. I really want to make something that feels fun. And system architecture constraints, wherein this system will be decomposed into 3 separate parts. The speech-to-text component, which are the ears, the LLM personality core, which will be the brain, and the text-to-speech component, which will be the voice. This forces modular architecture. Our success criteria will be, if I can push a button, ask Mr. House a question, and get a believable response, this project is a success. Before I do anything else, I need a blueprint. This project is really multiple systems working together, and if I want Mr. House to feel real, every layer has to cooperate. To start, let's look at the input layer. How does Mr. House hear me? We'll need a microphone, but more importantly, we need a decision. As previously stated, I do not want Mr. House to always be listening. An always-on microphone feels invasive. It also introduces noise, false triggers, and constant processing overhead. So as previously mentioned, we're using a push-to-talk button. When the button is pressed, he listens, and when you release it, he stops. Now when Mr. House hears something, it has to become text in order to feed it into the LLM. Speech-to-text doesn't understand meaning. It doesn't know context. It doesn't know who Mr. House is. It just turns sounds into words. At this stage, the system isn't intelligent, it's just transcribing. But accuracy and speed matter. If the transcription is wrong, everything downstream collapses. And if it's slow, the illusion breaks. Now we reach the brain. This is where most people think the magic happens, and it does, but only if you constrain it. Now, admittedly, my knowledge of the inner workings of LLMs, or even how to interface them, is pretty thin, so a lot of this project is going to be discovering that frontier. I know I'll have to tell the model that it is Mr. House in some way, but I don't know how that's going to happen. What I do know is that the LLM will return text, and we need to then convert that text into speech. From here, we're onto a fun part, the output. This is where we try to recreate that feeling of talking to Mr. House in Fallout New Vegas. First up, the voice. If this thing is going to work, it can't just read text out loud, it has to sound like Mr. House. That calm, calculated, slightly smug delivery. Now, voice models have come a long way, which is great, but getting something that really nails his cadence, that might be a tall order. Ideally, I would love to generate this audio locally, on my own machine, but I honestly don't know how painful that's going to be. I guess we'll figure it out when we get there. Visually, I'm keeping it true to the game. In New Vegas, Mr. House isn't walking around, he's just this giant static face on a CRT screen. That's the vibe. Not like the TV show where he's a video. The game version. Full retro terminal energy. And then there's the dialogue box. When you speak, the text that you speak should be entered into the dialogue box just like it is in the game. So it really feels like you're the courier standing there having this conversation. If we get all of that right, the voice, the CRT face, and the dialogue box, it should genuinely feel like you're sitting in the Lucky 38 talking to Mr. House. And finally, we need something to tie all of this together. Because right now we've got all these different parts. We've got ears, we've got a brain, we've got a mouth, but we don't really have anything that coordinates the whole operation. That's where the control layer comes in. Think of it as the conductor for an orchestra. It's telling each individual piece when to rise and fall, start and stop. It's the piece that makes sure everything happens in the right order. When you press the button, it tells the recording module that it needs to start recording audio. When the recording module completes its recording, it passes the recording into the speech-to-text model, etc. It doesn't do the thinking. It doesn't do the talking. It just makes sure that every one of the modules we've talked about before this all do their job at the appropriate time. It also handles all of the behind-the-scenes stuff, like keeping track of the current state of the application and making sure that different threads aren't stepping on each other. Basically, it keeps the whole thing from turning into chaos. Without it, everything would technically exist, but nothing would work. And with all that, I think we have enough to start moving on and building the software. With the planning done, it was finally time to start building. The first decision I had to make was, what am I going to build this with? For prototypes like this, I pretty much always reach for Python. It's flexible, fast to develop in, and basically every modern software tool has a Python library attached to it. It's not the fastest language in the world, but for something like this, it's more than adequate. And now for the framework. This isn't just a script running in a terminal. Mr. House needs a face, a presence, a window on the screen, and behind that screen, lots of different operations all working together. Listening, processing, speaking, and all without freezing the interface. So for this, I reached for Qt, PySide 6 specifically. Qt is a battle-tested GUI framework, and more importantly, it has a clean way for different parts of the application to talk to each other without turning into spaghetti code. It's built for applications where a lot of things are happening all at the same time, and that's definitely going to be happening in this application. Some of these choices were technical, some of it was experience. I've learned to just trust my gut. So with the stack decided, I built the simplest version of the software imaginable. A window and Mr. House's face. No intelligence, no voice, no grand ambitions. Just him staring back at me from the screen. It only took a few minutes to get that working, and with that, day 0 was complete. Not a bad start. I woke up the next day to find it was President's Day, which meant I had the rarest of all engineering gifts, an uninterrupted day. No meetings, no emails, no Teams interruptions, just me and Mr. House. So naturally, I took full advantage of it. The first thing I did was fix the layout. Mr. House was stretched kind of awkwardly across the screen, so I locked the scaling to the height of the image and let the sides go black. That seemed to make more sense to me from a layout standpoint. Much better. Now he was looking intentional. Centered, watching, unclipped at his head and chest. Then I added a dialog box that pops up when you hit the spacebar. Because if we're going to talk to him, we need somewhere for the words to go. And when you press space, I figured he should acknowledge you. So for now, I grabbed a clip of him saying yes. When you hit the key, he responds. It's simple, but it makes him feel like he's coming alive already. And yes, this was a prime opportunity to make a yes man joke. And I resisted. Mostly.
Yes. Mission complete.
So with that up and running, I started working on his speech recognition. After some quick research, I found that there was a library for Python called Faster Whisper, so I installed it and its dependencies. And the first time I ran it, nothing happened. Well, something eventually happened, but it just took forever. Turns out the first time you run Faster Whisper, it has to download the model in the background, which takes a while. Understandable. After I ran it the first time, it ran much faster every subsequent time. So, it was a self-solving problem. With that in place, I built a thin speech-to-text engine around it. You press R to record and S to stop. This mechanism ended up serving me quite well throughout the development of this application. At first I had some NumPy array issues. It turns out audio buffers care deeply about their size, but when I got that figured out, it was smooth sailing. I could talk and the words appeared in the dialog box. "Hey, Mr. House, I'm making an AI of you. What do you think about that?" There was a problem though. The transcription operation was blocking the UI. Now, when I say blocking, that means that one part of the application is taking control over the whole application and keeping the other parts from doing their job. We rectify this using threads in software engineering. And threading is just making it so that multiple parts of your application all run at the same time in parallel. What this meant was that while you were talking, everything in the application froze, which is not ideal. So I moved the speech-to-text operation into its own thread and used Qt's signals and slots to communicate. Now the interface stayed responsive while processing audio in the background. Tested, working, committed, pushed, crushed, diced, and sliced. And we aren't even 24 hours in. With speech-to-text working, it was time to start looking at giving him a brain. I created an abstract base class for the LLM, something simple with a generate response function, so that I could swap out LLM models if I needed to later on. Those words probably don't mean much to many people, but fundamentally what it means is I made a container where you could swap the brain out. Then I installed the OpenAI SDK. And I built a basic prompt steering system using their API, which is just a fancy way of saying that every time you generate a prompt, it gets preempted by a little message that says, "Hey model, you are Mr. House, behave in this way." So I wired it up, press record, spoke into the mic, and the app responded by asking me for money. Which is when I realized I hadn't set up billing yet. So I went to the OpenAI dashboard, committed $5 to this project, and generated an API key. An API key is essentially your key to unlock the processing power of somebody else's software that you're paying to use. I set the API key as an environment variable on my machine, reran the application, now looking for the API key at that location, and it responded in text, and I had a working version of Mr. House responding to my prompts. Very exciting. At this point, it was getting late, but I had come so far and I'd gotten so much done, I wanted to just get that last piece in, even if it was garbage. So before calling it a night, I slapped in a quick text-to-speech engine. Just something basic, a library that you can download called PyTTSX3. And it worked once, and then never again, and it sounded awful. "What's up? I'm Big Cons. What's your name?"
"I am Robert Edwin House, though most call me Mr. House. I run New Vegas and keep the strip functioning better than any of your rivals ever could. Now tell me why you bothered me, Big Cons."
Like a depressed GPS from 2006. But technically, I had achieved the full loop. Day one, and he already had ears, brain, and a voice. Not too shabby. Day two started with a small victory. I brought the prototype to work and showed a few people. It could listen, it could think, it could respond in text, which meant we were well outside the spectrum of just a weird weekend idea. Now he needed a voice. Before tackling speech, I moved the LLM response into its own thread. Same reason as the other. When he's processing in the background and trying to generate a response, it shouldn't be blocking any of the other operations in the application, including, especially, the front-end UI thread. Then I tried doing the same thing with the PySTXX3 library, and it worked once and then never again, which is becoming a recurring theme. Now, rather than trying to fix that issue, I just shifted gears and went straight to, let's make a better text-to-speech model. I did a pretty substantial amount of research into possibly doing this locally, and everything I read made it seem like that was going to turn into a year-long endeavor. And for these Doomsday Protocol projects, I don't have that kind of time. All signs pointed to 11 labs, so I went there to see what I could make happen. First, I wrote a generic TTS engine class that would allow me to swap the voice in and out at my leisure, similar to how I did with the brain and the LLM. Then I went down the rabbit hole of voice cloning. To do a pro voice clone, you need the creator tier of 11 Labs subscription, which is $11 a month, except it's actually $22 a month, and there's usage pricing. So that's fun. I went ahead and subscribed.
For science.
And immediately reminded myself that when I get tired of this project, I cancel this, so I'm not dumping $22 a month into Mr. House sitting there providing smartass remarks. I tried to do the pro voice cloning, which requires upwards of 3 hours of audio to do properly. And I ran into the issue of after submitting the material, it required a vocal authorization to ensure that I wasn't trying to clone somebody else's voice, which I was. But thankfully, the quick voice cloning feature, which purportedly has less fidelity but is just a kinda close enough approximation to a voice, is cheaper and doesn't require voice authorization. So I fed that about 10 minutes of audio, and honestly, hearing the playback, I realized it was really close. Like, really close.
Greetings. I am Mr. House. Big Cons designed me to interact with the world through my eerie green avatar, and that is exactly what I intend to do. The era of the House is upon us.
And the round trip time on that was about 1 second, which is really impressive. It felt like he was coming alive. Integrating that voice, however, was not as elegant. I built an audio player class to handle processing and playing audio within the application as it was generated, in theory. In practice, the audio system fought me the entire way. There was something about the audio coming off of 11 Labs API that I hadn't figured out at this point, and ultimately ended up resulting in me needing to install FFmpeg, which turned out to be not a huge deal, but man, I fought that every step of the way, and I probably spent upwards of 2 to 3 hours just trying to figure out why I couldn't get the audio to play through my application using just base Qt. Ultimately, I got audio playing using FFmpeg and 11 Labs audio player. It wasn't perfectly decoupled, but it worked. It was a minimum viable product, committed it, shipped it. Not really.
People of New Vegas, I rebuilt a jewel in the desert, so civilization need not end with the bombs. Embrace order and industry under my protection, and you will prosper. Chaos brings only ruin.
Now at this point, I realized the voice was great, but it sounded too clean. Mr. House in the game sounds like he's speaking through a tinny speaker box with a lot of room reverb. The audio coming out of the 11 Labs API, however, would just sounded like clean audio. So now I needed to add speaker box EQ filtering, slight reverb or slapback, and also the visuals at this point I realized needed some kind of effect. I started watching video from the game of interacting with Mr. House, and I noticed that his display had the telltale signs of an old CRT monitor with like a CRT scan line, and occasionally the image would roll, and I was like, well, if we want to make this immersive, we have to have that in there. Stuff that will help increase the immersion into the experience. Also needed to address the latency, because right now at this current juncture, the system was running and there was noticeable delay between when you recorded your question and when the response came, somewhere on the spectrum of like 13 to 15 seconds, way beyond anything that's even remotely immersive. So at this point, I started thinking I might need to implement some sort of first stage heuristic response. And what that means is basically something faster than an LLM that has some ability to respond within seconds that can provide filler audio to basically link to the generated response and make a more natural feeling conversation when you talk to Mr. House. By the end of day 2, he could hear me, think, and respond, and sound like Mr. House. And that was pretty exciting. So at the start of day 3, I did a little house cleaning. The dialog box needed a little work. I cleaned up the spacing, I centered things better. I made it feel less like a debug window, which I had been using it for up to this point, and more like an actual interface from the game. Then I moved on to the audio effects processing, which was a lot of fun. As mentioned before, the 11 Labs output was too clean. It was crystal clear, studio mic quality, but Mr. House doesn't sound like that. Mr. House sounds like a man who trapped his body inside of a tube and lived for 200 years with little vacuum tubes coming off his head, pumping information into a computer, digitizing his voice, and creating it so that he could interact with people through a tinny little speaker box on his desk. So in order to achieve this effect, I opened up Reaper and I started mucking around. I figured if I could dial the sound in Reaper using effects tools that are just built into the application, then it should be no problem to generate that same effects loop in Python in some way. After a bunch of tweaking, I landed on something close.
The House always wins. Stop wasting time. The House always wins. The House always wins.
A high pass filter around 500 Hz, a hard low pass shelf at 10 kHz, a moderate amount of room delay with slight pre-delay, and a narrowed stereo width. And in Reaper, it sounded fantastic and spectrally matched the source material. So then I had to translate that into Python, and that's where things got a little annoying. How does one run a proper DSP pipeline in Python? VST plugins? I looked into it. Reaper will technically let you use their VST plugins for free, which means I technically could load professional grade plugins into the app and use the signal chain that I had already constructed. But then I would have to ship this application with VST dependencies, and there's already a lot of stuff hanging on this application already. I didn't love that idea. And maybe I can make that work on my machine here, but I eventually would like to use this application on other computers. So adding fragile plugin chains didn't feel like the right answer. So I compromised and I tried some other Python-based DSP tools, which worked. Kinda. Using a library called Pedalboard made by Spotify, strangely, I was able to generate some basic effects chains. After enough tweaking and stacking low-pass filters on top of each other, I eventually got something that sounded pretty close to what I had achieved in Reaper. It was close enough that if you were comparing it A/B to audio from the game, you probably wouldn't notice. And in this case, that was the right call. One third option is I could have implemented the DSP myself using SciPy and NumPy, and I have been down that pipe before and I love stuff like that. However, in the interest of keeping things moving, I decided to forego it for this endeavor. And at some point you have to stop polishing and just keep moving. So I called it a day. And then nature intervened. Little did I know that the next 2 days would be completely lost. On day 4, I woke up to several feet of snow, and sometime during the night, the power had gone out. The office shut down, roads were buried, and our generator on our house decided that was the perfect time to start developing personality issues. So instead of building Mr. House, I spent my time troubleshooting very real-world life support issues. By day 5, I had gotten the generator running, which meant that certain parts of the house had power, but of course none of those parts included the computer I was using to develop this project on, so my time was spent keeping the fire going, making emergency supply runs, and when our internet was functional, doing any amount of work from home that I was capable of. Meanwhile, Mr. House sat there, unfinished, once again silent. Honestly, kind of feels on brand. 2 days gone. Sometimes the wasteland wins. After losing 2 days to snow and power outages, I powered up my computer and got back into development. The system worked, but there was a problem. Silence. When you would ask Mr. House a question, there was dead air before the LLM would get a chance to generate its full response and convert that into speech. It was enough time that it felt really bad. So first I cleaned up the entire audio chain by moving all the audio processing into a background thread. That put the text-to-speech generation, the MP3 decoding, the PCM audio conversion, the NumPy formatting, the effects processing, and the playback all in a thread, all being handled on the side. It wasn't the prettiest architecture I've ever built, but it was functional. Even with all that cleanup, the delay was still noticeable, and that brought me back to my thought of, we need some kind of first-stage heuristic response mechanism that can generate short-term audio to play while we're waiting for the LLM to do all its processing on the back end. So what if I had a smaller classifier whose only job was to classify the intent of the prompt? Not to answer it, just to decide how it should preface the response. Curious, dismissive, impatient? Then I could queue up a pre-recorded line instantly while the real response was generating in the background. My first thought was to use a recurrent neural network to do this. However, in the interest of rapid prototyping, I instead decided just to generate a heuristic classifier, which is really simple. I created a simple classification file that scanned the input text for certain keywords, indicating that the user was asking questions, was being hostile, was making a short statement, hadn't actually input anything, a whole number of different response types. Then I generated a small Python tool which would allow me to generate audio files pre-recorded, which I would then assign to the categories of response, allowing the first stage heuristic filter to identify the tone of the query and then pick a random audio file from that category to play quickly. And for this I generated a handful of filler responses like this.
Questions are the first step toward enlightenment. Allow me to help you comprehend.
To keep them snappy, I used my Python tool to generate and record them with all the effects processing and stored as WAV files, so there was no processing loop involved in playing them. They simply were called and opened instantaneously. So now when you speak to him, he reacts immediately, even though the full response is still cooking in the background. And that tiny change made a world of difference. But there was still latency. So in order to reduce the latency, I switched the LLM model I was using from the most recent, most intelligent GPT-5 model, which honestly Mr. House doesn't need, to an older 3.5 turbo model, which is wildly faster, on the order of 3 to 4 seconds compared to the 8 to 12 that the other model was taking, and considerably cheaper to use per use. Which is ideal because at this point I'm using 2 paid APIs and I'm pretending not to think about it. So with that, the only real challenge at this point was I needed to make sure that when the second response arrives, it doesn't step on the first response that's in the middle of speaking. And also the screen still needed more life. The tiny details that would make it feel like this application has been running for centuries. And at some point I needed to build the button because that's part of the spec. Regardless, by the end of day 6, he responds immediately, he speaks with character, there's limited delay between his initial response and the generated response, and he feels reactive, not just responsive. On day 7, I did some wrestling with some audio pipeline stuff, which is
Boring.
But what's exciting is that on this day, Mr. House had his first real conversation with somebody who wasn't me.
Hi, Mr. House. Matt wants me to talk to you, but I don't know what to talk to you about. So maybe you can give me a really good soup recipe to make that's vegan.
I tire of this drivel. Ah, a request for culinary expertise. How refreshing. Allow me to provide you with a recipe for a delectable vegan vegetable soup.
Hi, Mr. House. That was really useful information. Thank you so much. I'm really glad you're here with us.
I tire of this drivel. Your gratitude is duly noted. Remember, my presence is not for companionship, but rather for strategic guidance.
Don't worry, bro. I don't think anyone was looking to you for companionship, so you can go ahead and it off with that.
You deserve a precise answer. I am not one to seek companionship. My focus is on securing the future of New Vegas. Your crass language and attitude have no impact on my plans.
Best of luck to you, and I hope that your Mojave Waste project goes better. Oh, someone's phone's ringing. It's mine. Bye.
I tire of this drivel.
Okay, she was only supposed to ask him a couple questions. I didn't think that was going to go off the rails like that. That was incredible. And I was just losing it watching that play out. With Mr. House able to carry a conversation, it was time to start working on his aesthetics. To wit, I created a dedicated CRT widget, which included alpha blending along the edges, CRT scan lines as previously mentioned, random gamma increase and decrease for flickering effect, and occasional screen roll. And thankfully, I didn't have to write a custom shader, which I hate doing. Huge win. Finally, it started to look right. Not like a modern monitor on a desk, but like an ancient CRT screen that has survived a nuclear apocalypse. It looked eerie and haunted, and I love that about this. Up until this point, everything has lived inside the computer. Keyboard presses, background threads, audio buffers. It all worked, but now it needed that extra something. And that extra something was the large red button I wanted to have to start and stop the recording. I've done something like this before, and the idea is pretty simple. You take a button, you wire the button to the GPIO on a microcontroller, and you use the microcontroller's USB interface to send a simple serial command back to the computer to let it know that the button is pressed. That's it. No complicated data, no streaming, just a clean transaction of serial messages. So to start, I designed a slightly over-the-top pedestal to install the button into. I designed it in CAD and sent it off to the 3D printer for printing. While that was printing, I turned to the brains of the operation, the small Raspberry Pi Pico microcontroller I was going to use to interface to the button. Using the Platform I/O plugin for VS Code, I stood up a simple application to load onto the Raspberry Pi Pico, which would cause the LED inside of the button to breathe. A breathing LED is that slow fade in and fade out an LED can do. I've always really liked that effect because it makes a device that is idle seem like it's alive, and also lets you know if the device is actually functioning because the LED will breathe in and out as long as the code is proceeding. From there, I added a button debounce algorithm and a simple plain text serial protocol. I did lose a few minutes during this whole process by accidentally mistaking the numbers on the Raspberry Pi Pico's board with the GPIO numbers that the code actually expected. It was a small oversight, a quick fix, but also a humbling reminder that fundamentals matter. By the next morning, the button's pedestal was done printing. I hit it with a quick coat of gold spray paint, which felt appropriate for a button designed to summon a egomaniacal tech mogul. And then I went to work, eagerly anticipating the moment I could return home and plug the whole button system into Mr. House's application. Later that evening, I got home from work, wired it up, plugged in the button, pressed the button, and the whole thing broke. See, adding that button meant that I had to add another background process to the application that was constantly monitoring the USB for that message that said the button was pressed. And that exposed a flaw I didn't know that I had. Up to this point, I had been using some lightweight threading mechanisms, kind of a good enough way to run processes in the background. And they worked fine when things were simple, but we had just added another concurrent thread to an already kind of cluttered system. So now I had audio playback going in the background, text-to-speech processing, LLM response generating, visual updates, and a live serial connection from the button, all going at once. This new thread revealed synchronization issues between all the other threads. I did everything I could for about an hour to try and patch around it, but it was futile. Eventually, I had to admit that I needed to refactor some of these threads into more robust queue threads, where before I had been using a lightweight thread mechanism called a queue runnable. So the next night I came home and got immediately to rewriting all of the lightweight queue runners with actual robust queue threads. It took several hours, but slowly, system by subsystem, I eventually got Mr. House back into a working state, working even better than ever, and now the button press was registering properly. When it finally stabilized, I feel like I had really achieved something and really brought the overall architecture of the whole system into a more coherent state, which felt good. With the external hardware and the core controller architecture stable, I turned back to more aesthetic and tidying up aspects. So for the rest of the night, I sat in front of the keyboard generating filler audio until midnight, when I got it all working perfectly. By midnight, I had over 50 pre-recorded audio clips with effects implemented, ready to go. The effect was dramatic. You press the button, you speak, he responds instantly, and then it transitions to the LLM response almost seamlessly. Sometimes a little too seamlessly. Hey, Mr. House, how you doing tonight?
Ask something worthy of my time. I'm functioning at peak efficiency, as always. What can I assist you with?
I just wanted to tell you, I'm feeling a little tired. It's been a long night, but we got a lot of good work done tonight. How are you feeling about that?
An intelligent question for once. As long as progress was made, fatigue is a trivial concern. Efficiency is paramount, and results speak for themselves. Rest is for the weak-minded.
Oh, Mr. House, you're a man after my own heart. The whole system was feeling very natural and alive, which was great because little did I know things were about to get bumpy for a couple days. Work ramped up, time got tight, and then that following Friday I went to the doctor and got a COVID booster shot, which then subsequently put me down for the remainder of Friday and for most of Saturday. And suddenly I woke up Sunday morning with one lingering issue. Sometimes the LLM-generated audio response would start playing before the filler audio was complete, which really broke the illusion when it happened. So there I was Sunday, the final day of development, with a cutoff at 5 p.m. The fix seemed simple in theory. Just make the second audio wait for the first audio to be complete. However, all of these happen in different threads, and the audio pipeline for the immediate wave playing output was completely different than the MP3-based audio output that the LLM-generated response experienced. I was resistant to it at first, but eventually what I did is combine the two players into one class and have them share a semaphore to indicate to the overall class whether the wave file play was in process or not. Still coming down off of my COVID booster shot, I fueled myself with ibuprofen and cold brew coffee. And at 4:37 p.m. with a hard 5 p.m. cutoff time, well, here were the results. My name is Big Cons. Please introduce yourself.
That variable was already anticipated. I am Mr. House, the founder, chairman, and CEO of Robco Industries. I am the sole owner and ruler of the New Vegas Strip and its surroundings. How may I assist you, Big Cons?
I wandered into your Lucky 38 casino tonight, and I'm just a wandering courier in the wasteland.
Statistically unremarkable. Welcome to the Lucky 38. I trust you are here for a reason, not merely to gawk at the wonders of New Vegas. Speak your business.
I ended up tangling with Caesar's Legion, and they told me that Benny here on the Strip is responsible for shooting me in the head.
Statistically unremarkable. Ah, Benny, always the schemer. He's certainly caused quite a stir. Seek him out and deal with him as you see fit. Just remember, in this city, the game is played by my rules.
All right, sounds good. I'm headed out. It was a pleasure meeting you, Mr. House.
Noted. The pleasure was all yours. Remember, the house always wins. Safe travels.
What an absolute blast that was, top to bottom. 14 days of building things, breaking things, rebuilding things, sometimes breaking them again, and cobbling together an almost Frankenstein's monster of a system. And honestly, I couldn't be more proud of it. He's engaging, he's entertaining, and although he rarely has any advice that's actionable, that was never the point. The goal was simple: bring Mr. House to life, and I genuinely feel like we pulled that off. This project was also a huge learning experience for me. Up until this point, my experience with large language models has largely been the same as everyone else's. I was a consumer. I asked questions and I got answers. But actually building a system around one was a uniquely different experience. You start to realize how many moving pieces are involved: the model, the threading, the timing, the audio, and the little tricks you have to do along the way to make the interaction feel natural. And even after 2 weeks of hard work, I feel like I barely scratched the surface of what's possible. The voice cloning alone is truly remarkable. Considering how little time and effort I was able to put towards that, the results are honestly wild, and it really helps to sell the illusion of Mr. House being there. And that's the moment where the whole project suddenly feels real. Now, of course, like any engineering product, there are 1,000 things that I would love to continually refine. I notice every little audio glitch, and anytime a thread misfires even a little bit, it irks me. And after talking with a few friends, I already have a list of ideas of how to tighten the audio loop and reduce latency. Also, technically speaking, in the game, Mr. House, I think, can see you. So giving him a camera and experimenting with the model responding to visual cues would be a maybe interesting next step to pursue. However, we are at the end of our 2 weeks and we met our project requirement, and I probably won't go down that rabbit hole just yet. One thing I did very intentionally during this build was to keep Mr. House's inner systems modular. Under the hood, Mr. House isn't really hard-coded as Mr. House. He's more like a personality layer sitting on a collection of subsystems, which means that swapping him out for another personality could be fairly straightforward. Someone like Victor, or the Gatekeeper, or Muggy, or Jane, or perhaps someone a little more agreeable. There are some characters in the Fallout New Vegas universe that would make for a very interesting future Doomsday Protocol build. For now, though, Mr. House has done his job. And the funny part is, because I ended up using the fast voice clone from 11 Labs, it turns out Mr. House will actually only cost me $5 a month to keep alive, so there's a chance he might continue to live, maybe on a little Raspberry Pi attached to a television in the corner of my office, just continuing to silently judge every decision I make. Silence unless I cue him to talk to me, that is. But for this project, the clock stops here. 14 days, one fully functional Mr. House, and one more completed Doomsday Protocol. Thanks for coming along for the ride on this one, and until next time, stay frosty.